Hello good day viewers. In this tutorial we are going to verify which one is greater between e to the pi or pi to the e. But before we start, you should know that pi is greater than e. Pi is greater than e. Why? Because pi is approximately 3.14 while e is approximately 2.72. You see, this number is definitely greater than this. Another thing you should know is that if two bases are exactly the same, that number with the highest exponent is always the greatest. So now let us transform this e to the pi and pi to the e a little bit. We know that e to the pi can be multiplied by e divided by e. You know, e divided by e is nothing but 1. Likewise, we can do the same thing here. Pi to the e, we can multiply the exponent by pi divided by pi. You know, pi divided by pi is still 1. Therefore, this becomes e to the power of 1 divided by e, also raised to the power of what? Pi e. If you multiply these two together, you shall obtain this back. You equally do the same thing here. We have pi raised to the power of 1 divided by pi, also raised to the power of pi e. Now you can see that the exponents are exactly the same. The question is, which one is greater between e to the 1 divided by e and the pi raised to the power of 1 divided by pi? We still don't know, but it looks exactly as x raised to the power of 1 divided by x, right? So it resembles x raised to the power of 1 divided by x. If that is the case, let us graph this function. You should know that x raised to the power of 1 divided by x looks somehow like this. Somehow like this. And on x-axis, you should know that pi is in front because it is greater than e. But we cannot actually locate e and pi on the curve because the curve is not constant. Therefore, let us try to find out where this curve is maximum by differentiating the function and set it to be equal to 0, because the curve is maximum when the first derivative is equal to 0. So let's assume we have this function to be y equal to this. If y is equal to x raised to the power of 1 divided by x, we can take natural log of both sides. We have natural log of y to the left, and this is equal to the natural log of x raised to the power of 1 divided by x. Apply one of the laws of logarithm, this power can drop down to multiply. So we have natural log of y to the left. This is equal to 1 divided by x multiplied by the natural log of x. Now we are free to differentiate both sides. If you differentiate natural log of y, you shall obtain 1 divided by y. Because y is a dependent variable, you have to multiply by y prime, which is the same thing as dy over dx. This is equal to, because we have a product, we are going to apply product rule. You keep the first function constant, you differentiate the second. If you differentiate natural log of x, you shall obtain 1 divided by x. This time around we're going to keep this constant and differentiate this. If you differentiate 1 divided by x, you shall obtain negative 1 divided by x squared multiplied by natural log of x. Now let us simplify it a little bit. This is equal to, if you multiply these two together, you shall obtain 1 divided by x squared. Then minus plus is minus. We have minus 1 divided by x squared multiplied by natural log of x. You can see we have 1 divided by x squared in common, so let's factor it out. This is the same thing as 1 divided by x squared multiplied by 1 minus natural log of x. Remember, to the left we have 1 divided by y multiplied by y prime. But we are looking for y prime, so we can multiply both sides by y. So you multiply this by y, you equally multiply the right hand side by y. But what is y? Y is nothing but x raised to the power of 1 divided by x. So to the left hand side, this will cancel this. We only have y prime equal to x raised to the power of 1 divided by x multiplied by 1 divided by x squared multiplied by 1 minus natural log of x. This is just the derivative of y with respect to x. But I told you our function or our graph is maximum at a point where the first derivative is equal to 0. So we're going to set y prime to be equal to 0 just to obtain the value of x at that particular point. So if we set x raised to the power of 1 divided by x multiplied by 1 divided by x squared multiplied by 1 minus natural log of x to be equal to 0, it implies either this equal to 0 or this, these three functions. But you should know that this is strictly positive number greater than 0, right? And also this cannot be equal to 0 because we don't want any situation that will make our denominator to be equal to 0, which will make it undefined. This means that this is what? Equal to 0. So 1 minus the natural log of x must be equal to 0, which means what? Natural log of x is equal to 1. And you know natural log of x is a log of x to base e, right? So what will be the argument x? X is nothing but e raised to the power of 1 if you transform the logarithm into exponential form, which means what? X must be equal to e. So at this particular point where the curve is maximum, this particular point, if you drop down, you're going to obtain e. So this is the real e, not the other one. And still pi will be in front. So what happened if we substitute the value of e into the main function, because the main function is what? X raised to the power of 1 divided by x. We can equally substitute the value of pi, and the output here will be less than that of e, because if you substitute e, you're going to obtain e raised to the power of 1 divided by e in the function. And if you substitute pi, you're going to obtain pi raised to the power of 1 divided by pi, which means that e raised to the power of 1 divided by e is greater than pi raised to the power of 1 divided by pi. So now let us take this function, simplify it in terms of what was given to us initially. So since we have seen that e raised to the power of 1 divided by e is greater than pi raised to the power of 1 divided by pi, we can multiply their respective exponents by what? E pi. You know, multiplying the exponent by the same value will not change them. So this is what we have. You can see that this will cancel this, pi will cancel pi here. Therefore, we have e to the pi greater than pi to the e, and hence e to the pi is greater than pi to the e. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.